Inheritance is a technique where I can define a relationship between two classes such that one class takes on or inherits the members of another class. So if class A has one method, do work, then class B can also have that same method just by inheriting from class A and not writing any additional code but reusing the code already in the first class. If class B wanted to have an additional method, it can. The syntax for inheritance is to use a colon after the name of your class, and then you specify the base class, that is the class whose members you are going to inherit. We've already seen some inheritance in this course when we defined a custom event arguments class for the gradebook's name changed event. All events in .NET should pass an arguments parameter that inherits from event args in the framework class library. You can only inherit from a single class in C#, that is, you can only specify a single base class after the colon, but the inheritance chain is unlimited. You can have class C inherit from class B, which inherits from class A, and in that case, class C is inheriting all the members from B and A. So class C would also have a do work method. You do have to be cautious with inheritance because it does tie up your classes and your code into a tightly bound relationship. I talk about that more in the Programming Paradigms course. For now, let's take a look at inheritance and code. Inside the grades project that we've been working on throughout this course, let's imagine that our users came to us and they've told us that occasionally they want a gradebook that will throw away the lowest grade before computing statistics. That will allow a student who has a bad day or one bad assignment to not be penalized as much for that one bad grade. And this is something that the users occasionally want to do. They don't want to get rid of the original algorithm for the gradebook. They just occasionally want to compute statistics and throw away the lowest grade. Now, what are some different approaches to implementing this? Well, I could take all of the code in the gradebook and press Control A and copy this code and paste it into a new class. Perhaps we'd call it the throwaway gradebook. And then I could go in and tweak the code and tweak compute statistics to throw away the lowest grade before doing the rest of the computations. But this copy and paste approach can lead to a lot of duplicated code inside of an application if that happens too often. So another approach might be to modify the existing gradebook, perhaps add a public property, throw away lowest. And if I'm in a situation where the lowest grade needs to be thrown away, I could always instantiate the gradebook and then set this property to true. And inside of compute statistics, check this property. And if it's true, run a little bit of code to remove the lowest grade and then continue with the execution that's computing the statistics. That's another approach. And the approach that ultimately I would take really depends on the team that I'm working with and the type of application I'm building. And most importantly, the business. Where else do I anticipate that the business might want to make changes to the gradebook or the algorithms that are involved? And in some of those scenarios, I would use inheritance to solve this problem. And that's the approach that I'll show you today. Let's go into the grades project and add a new class. I will call this the throwaway gradebook because it will throw away the lowest grade. And I want this to also be a public class. And this is a class that I want to inherit from gradebook. So at this point, throwaway gradebook has all of the same capabilities as a regular gradebook. In fact, I can come into program.cs and instead of instantiating a gradebook, I can instantiate a throwaway gradebook, and I can take that object and assign it to a variable of type gradebook. We would say that the throwaway gradebook is a gradebook because throwaway gradebook inherits from gradebook. It's a specific type of gradebook. And in C#, you can always take a derived type and assign it to a variable of a base type, and that's completely legal. At this point, I could even run the program. First, let me comment out this line of code that would force me to input a gradebook name. I can run this program with Control F5, and I can see that we're still outputting the same numbers that we had before. The average is 85.17, and the lowest grade is a 75. So currently, this new throwaway gradebook object behaves just like a regular gradebook. Now what I want to do is have compute statistics behave a little bit differently. I want it to throw away the lowest grade. So on the throwaway gradebook, let me create a public method that will return an object of type grade statistics. This is also called compute statistics. And inside of here, I want to reuse the existing algorithm that is inside of the gradebook as much as possible because it's already doing the hard work of the calculations. And I can do this. You might remember earlier in the course, we talked about a special implicit variable that's available inside of every instance method that is non-static method, and that's the this variable. This is a keyword in C#, and this allows me to reference the object that I'm currently inside of. And I can see in the IntelliSense window, I can reach methods that are on my object instance, methods that I've inherited, methods like add grade and compute statistics. There's another keyword in C#, a special implicit variable. It's called base. And what base will allow me to do is reach specific methods in a class that I've inherited from. So in this case, when I say base.computeStatistics, I'm really referring to that compute statistics method that is available from the gradebook. And ultimately what I could do is just say return whatever that compute statistics method comes up with that will use the existing code inside of the gradebook. But before I invoke that compute statistics method in my base class, I need to remove the lowest grade. So let's declare a variable of type float. I will call it lowest and initialize it to float.maxValue. And what I need to do is loop through each grade that is in my grades collection, except I cannot reach the list of grades from the throwaway gradebook. Notice the error is that grades is inaccessible due to its protection level. Over in the gradebook, you might remember that when we created this grades field, this list of grades, we marked this field as private. And the only code that is allowed to access this field is code that is inside of the same class, inside of gradebook.cs. But I do want to give the throwaway gradebook access to these grades. Now, I don't want to make grades public. That would give everyone access to this field. I need something in between, and that in-between level of access is protected. So a public member, anyone can access. A private member, only code inside of the same class can access. A protected member, whether it's a field or an event or a method, a protected member you can access from code that is in this class or code that is in a derived class. And by marking grades as protected, I should now have access to that field from any class that ultimately inherits from gradebook. And I could now say lowest equals math.min between the grade that I'm looking at and my existing lowest score. And when that loop is finished, I should have the lowest grade in that variable. And now there's a very convenient remove method that I can use on a list. And I could say grades.remove this lowest item. Now there's a couple situations I should be careful with in this code. I should be careful if there's only one grade in the grades collection, or if there's no grades in the grades collection, or if someone's going to call compute statistics multiple times and keep removing grades. Those are all situations I need to worry about, but I'm just making you aware of those. We want to focus on inheritance, and this is about the simplest possible thing I could do to remove the lowest grade. So let's run the application again, and you'll notice I'm getting the same results as I did before. The average is still an 85.17, and the lowest grade is still a 75. What's going wrong? Let's debug this a little bit using console.writeLine. Sometimes console.writeLine is easier than using the debugger itself. Here I'm going to say that we are inside of throwaway gradebook, compute statistics. And I'm going to take this line of code and go to the gradebook and paste that line of code into compute statistics, just so I know when we are inside of the gradebook compute statistics method. Let me run this program again, and I can see that clearly I'm invoking compute statistics on the gradebook, even though inside of my program, I've instantiated a new throwaway gradebook. So this isn't quite the behavior that I want. I want to be able to instantiate a throwaway gradebook, and I want that new version of compute statistics to work when I instantiate that gradebook. So let's take a look at solving that problem in the next clip. But right now, I just want you to know that we have an inheritance relationship now between throwaway gradebook and gradebook. Anything that I can do with a gradebook, I can also do with a throwaway gradebook. And when this program executes, I really am executing against a throwaway gradebook. That's the type of object that I pass to write results and save grades and add grades. It's just that we need it to work a little bit differently. So let's talk about that next.